All right, so I'm going to give you a little bit of a visual as to what we're going to discuss today. So we're going to discuss dependent versus independent events, or you can call it dependent versus independent probability. So just look up here for a second. So if I were to flip this coin and it lands on heads, right? So we record that event. Is that going to affect what's going to happen next if I flip it again? Is the second outcome going to be affected by my first outcome? You landing heads will not really affect your second one, would it? Unless you're superstitious, of course. But if all else aside, the number of possibilities is always 1 out of 2 with a coin, right? It's always 1 out of 2. Every time I throw it, I toss it, it's 1 out of 2. Oh, that's actually heads, right? So I was landing on tails the whole time. I'm like, that's a deer head. Anyways, so the number of outcomes does not change. It's always 1 out of 2 every single time you toss it. Let's put that aside. If I have a die, if I roll it, I get a 3. Okay. Chances to get a 3 the second time is still 1 out of 6, no matter what happens. It's always 1 out of. Oh, I got it again there. But it's always 1 out of 6. Chances of rolling any number on this is always 1 out of 6, no matter what. No matter what I rolled before. But how does that change? How can that change? Deck of cards is a classic example of that. If I were to just draw a random card and I get a queen of is this clubs? Clubs. Sorry, I have to get I don't know my cards sometimes. So if I put that aside, so at the very first instance, to get a queen of clubs would be 1 out of 52. If I take that out, what's the probability of getting another queen of clubs? It'd be 0, right? There are no queen of clubs left. But just a queen in general. How about just a queen in general? If this is out, just grabbing a queen, what would the probability be now? How many cards are left? I started with 52 when this was in here. I take this out. How many cards are left now? 51, right? And how many queens left? 3. So this first event has affected what happens next. These are called dependent, right? This will depend on what happens, right? Next, or the second event will depend on what happened first. So that's what we're gonna discuss today. I want to introduce that. And the key thing is here, when you remove and do not replace, right? You remove something from the total, you do not replace that. That's when we have this dependent situation. If I were to replace this, like I draw an 8 of diamonds and I put it back, then it's nothing really changes. It's like everything we've done up until this point. But if we remove it, like chocolates, right? In a box of chocolates, you remove it, you eat it. Now there's fewer chocolates left. So you will see marbles and stuff like that where we don't replace it. We're talking dependent events. However, with a die, you can't remove an outcome. Like even if you roll it, the 4 stays on here. You still have 6 options every time. Okay, same with a coin. You can't remove an option. It's always 1 out of 2. Okay, so let's keep that in mind as we go along. Maybe another example, Monopoly or whatever, McDonald's, when they have their promotions going on, right? Or roll up the rim. As people win prizes, the chances of you winning it diminishes, right? Gets lower and lower because there's only that many prizes. So as soon as people start cashing in their prizes, so that would be a dependent probability as well. Same thing there. If your teachers make groups and you get selected, if I'm selecting someone for a group, chances that you get picked at the very beginning would be 1 out of, today it'd be 1 out of 23. But if I take a student out of that group, now the chances that I pick you next is 1 out of 22. And then it's 1 out of 21. Until you get picked, of course, now you're out, right? So yeah. So let's talk about this a little further and we'll do some examples. So this part here is new, okay? That is new to us, the dependent part. The independent is what we've been doing up until this point already. So independent events, grab a highlighter. Independent events is where the first does not affect the second. In other words, the total possible outcomes remains the same. So here's some examples. If you draw a card, record the results, and then replace it. Let's highlight the replacing part. Before drawing another, the total number of cards remains unchanged. Rolling dice does not affect the total number of outcomes for a second roll, even a third or fourth or whatever, etc. You record your results and roll again. Nothing changes. So that's what we call independent events. Dependent events is where it changes. I'm going to grab a different highlighter. This is when independent events is when the first event affects the total number of outcomes for the second event. And you know that when the question says they're not being replaced. However, I am a little sneaky sometimes. I might not say no replacement, but I will say in a chocolate example, someone grabs the chocolate and eats it, right? You should realize, okay, that obviously is not being replaced. So it doesn't happen very often, but sometimes I do. When cards, marbles, candies, etc. are not being returned after being drawn, right, it affects the total number of outcomes. So example, your teacher, I already talked about this, right, making groups. The chances of you being picked next increase since the number of students remaining, right, the total outcomes is decreasing. So keep that in mind. Let's do some examples here and put it to the test. Okay? So we have a bag of marbles, has 3 reds, 5 blues, and 2 greens. That is a total of 10. Okay? Total 10 marbles. So let's read the question. If a blue marble is chosen, so this is what I would call the first event. If a blue marble is chosen and it's not replaced, let's highlight that, not replaced, what is the probability of drawing a red marble next? So this here is my second event. And this word not replaced places this question in the dependent category. This event will affect the second event. Right? These two things are dependent on each other. You can't fail to mention this to someone. If you do not talk about the first event in this case, you're getting the wrong probability. Okay? So let's come up with that probability of red. Let's look at our bag here first. Let's get rid of the blue marble because it has not been removed. So let's cross one of them out. That means that instead of 10 original marbles, you're down to 9, right? So we're going to go 10 minus 1. It's the one we're removing. And how many reds are left? There are still 3 there. So the number of reds has not been affected by the first event, but the total has been. So this is 3 over 9, which is 0.3333, which is 33.33%. Mr. Erickson, do I have to do the 10 minus 1? Is that really relevant? No, you don't have to. I think I just like you to see that it's happening. Let's do another example. Make sure you follow along. Try your best to follow along. If a blue marble is chosen, so that's my first event, and then not replaced, okay, that should be like a 10, 10, 10, right? State the probability of drawing another blue marble. So this is my second event. Let me come down here. So a blue marble is chosen and not replaced. So I can go and get rid of another blue here in this scenario. Let's go dependent again. So probability of blue, right? Watch what it says. Like, what is the probability of now drawing a blue one? I used to have 10, correct? Took away 1. It was a blue one, but it doesn't really matter down here. It's just like the fact is that you're removing a marble from the bag. What about the blue ones? You used to have 5, but you've removed a blue one, so technically you're down to 4. So in this scenario, after the first event happened, you're down to 4 blue and 9 in total. Does that make sense? So just look at the bag here. You used to have 10. You got rid of the blue one because that was chosen and not replaced. It was taken out. So it's as if it's not even there. So then basically you're down to 4 blue ones because that's the probability you're after. So 4 blue 1 over 9. So what's that as a decimal? 0.4444, comma, and that's 44.44%. I just don't want you to forget that, but that's how that works. One more example. If a red marble is chosen, so this is my first event. And what does it say here? It's replaced, correct? I'm going to use my other highlighter that I used for independent. Independent. i.e., nothing changes. Okay, nothing changes. To be honest, I don't even have to tell you the first part of the story because you're replacing it. So what does it matter? I could have completely ignored this. So it just goes back to what we've been doing all along. So probability of red, it says you picked a red one, you replaced it. What's the probability of getting another red one? It's going to be the exact same. So it's going to be 10 total. And we have 3 reds, right? So it'd be 3 out of 10. And so that's 0.3, which is 30%. Let's make total unchanged. Total is unchanged. It stayed exactly 10. But notice this. Let's look at a pattern. Every time we had dependent situations, our total came down to 9, right? Here, it was replaced, it stayed 10. So the total definitely has to change. The numerator, it'll be up to you, up to the scenario there. Okay. I don't want you to pack or check your phones right now. I want you to go to page 50 and try those questions right away. I want you to try. I want you to read. I want you to attempt. The risk of you getting it wrong might be high, but there's not really any consequence, right? you're going to learn, hopefully. So answer that. I will tell you which pages I want you to try. Well, let's do this one first, and then I'll tell you which pages I want you to try on your own after we're done today. Okay, just try this page before we go, okay? Page 50, question D. Green marbles drawn, not returned. What's the probability of drawing another green? So you go to your bag, you realize I'm getting rid of that one on the first event. So probability of another green would be 1 out of 9. Okay. If you draw a blue first, let's get rid of that blue because it's not being replaced. Then a green one, let's get rid of the green one. What's the probability of drawing a red marble on the third draw? You've removed 2, so you're down to 8. And red one, there's 3 reds left, so that'll be 3 out of 8. Simple as that. Okay. A red marble is chosen first, then a green one. They're both replaced. Independent. No change. This is really irrelevant. If there's replacing, then this doesn't really matter what happened before. It's like basically it's a reset of the original situation. Oh wait. I'm one line off, guys, sorry. So much for not confusing you, right? Oh boy, sorry guys. It's not replaced. So the red one is gone. The green one is gone. Because we're not replacing it. The probability of drawing a red one on our third draw, we have 2 red ones left. So sorry about that, guys. That's 1 over 4. That's 0.25. That's 25%. There you go. Hopefully you didn't erase it. I would feel bad if you did. A green marble is chosen first, then a green one, another green one, and they are returned. This is independent. What's the probability of a green one on the third draw? It's still 10. We still have 2 just like at the beginning. That's 1 over 5. That's 0.2 or 20%. This is irrelevant. It can be omitted. Right? It doesn't matter what happened before because you're replacing, you're returning. Okay, before you pack, right? So is it honest mistake? Okay, yes. It happens here. Homework. Pages 51 to 53 will be posted. Oh, Mr. Dirksen won't check. Mr. Dirksen will never find out. But you will benefit from doing it. So do it because of that. Okay? I will throw an AC at you probably. So I will post these pages, which has more of this, but it has the cards as well. So keep that in mind. Thank you, guys.